talking of the mean or average value of the alternating EMF or voltage, we define mean or average value of alternating EMF or voltage for a half cycle. It is defined as that value of steady EMF or voltage that will send the same amount of current through a circuit as is sent by the AC through the same amount of time as the AC is passed through that circuit. Let E be the instantaneous EMF, that is equal to E0 sine of omega t. Taking the current from here, I is equal to E0 divided by R sine of omega t, where R is the resistance of the circuit. Let for a small amount of time, that is dt, let us take that the alternating EMF or the voltage is constant. So for that amount of time, let dq be the charge passed through the circuit. Now after that, we will integrate that charge from 0 to t by 2, and we will see what is the total amount of charge that is passed by the AC through the time 0 to t divided by 2. So we have that here dq is equal to I dt. So we have dq is equal to E0 divided by R sine of omega t dt. Now integrating this from 0 to t by 2, we get integrating it from 0 to t by 2, dq is equal to integral of 0 to t divided by 2 E0 divided by R sine of omega t dt. Differential and integral cuts out, so q comes out to be E0 divided by R is a constant, that is integral of 0 to t divided by 2 sine of omega t dt. Now we have q is equal to E0 divided by R cos of minus cos of omega t, and integration comes out to be 1 by omega. The limits are 0 to t divided by 2. Solving it, we have q is equal to minus E0 divided by R omega, giving the limits, that is cos of omega into t divided by 2 minus cos of omega into 0 to 0. So q is equal to minus E0 divided by R omega cos of 2 pi by t into t divided by 2 minus cos of 0 degrees. So t and t gets out, 2 and 2 gets out, giving the values cos of pi is minus 1, so E0 divided by R omega into minus 1 minus 1. Solving it, it comes out to be minus 2. Minus 2 into minus 1 is equal to 1. So q comes out to be E0 twice E0 divided by R omega. Now let us take the value, mean or average value of the alternating EMF be EM. So that EMF should pass the same amount of charge through the circuit as is passed by this AC. So we have that, taking current from EM, so we have EM divided by R is equal to Q divided by T divided by 2. Taking Q from here, so we have EM divided by R is equal to twice E0 divided by R omega into T divided by 2. R and R cancels out. So EM is equal to twice E0, taking omega is 2 pi divided by T into T divided by 2. 2 and 2 cancels out, T and T cancels out. It comes out to be twice E0 divided by pi. So EM is equal to twice E0 divided by pi, where E0 is the maximum value or the amplitude of the alternating EMF, and EM is the mean or the average value. So EM is equal to 2 by 3.14 into E0, that comes out to be 0.637 E0. So we define the mean or the average value of the alternating EMF as equal to 0.637 times the peak or the amplitude of the alternating EMF. Taking percentage wise, we can say that EM is equal to 63.7% of E0. So mean or average value of the EMF is equal to 63.7% of the maximum value of the AC, that is also called as the amplitude of the AC. Thank you.